Hello everyone, how are you guys doing? I hope you're all doing amazing. Welcome to another video. Without wasting too much of your sweet time, let's get started with today's problem, which is product of array except self. In this particular problem, you are given an integer array nums where you want to return another array answer where answers of I is going to be equal to all the products inside nums except nums I. So as the question name spoke for itself, you basically want to return all the elements product at each index except the element which is present at that index. Now, how can we go about doing this? Well, this is pretty straightforward, right? Why is this supposed to be a lead code medium problem? You have all the nums inside right here. You can calculate the product of them at once, which is going to take O of n time, and that is going to be 24 in this case. And while I'm traversing the array, I'm going to divide that particular product with each of these elements, and I'm going to get that particular answer size. So yeah, done and dusted. So often solution done pretty quick, right? Well, there's a catch in the problem. So if you just read the question a little bit deeper, you will see that you must write an algorithm that runs in often time without using the division operation. So how can we go about doing this? So let's take this problem straight to the whiteboard and try to think about it there. So here we are. Let's write down our example, which is 1 2, what was it, 3 4. Yeah. I think I just forgot counting there for a second. And we are going to return 24, 12, 8, and 6. So this is our answer that we are supposed to return for this particular case because we don't want to include the particular element during our iteration. That's what the problem is asking us to do. So how can we go about doing this? Well, first of all, as we do in any other problem, first of all, let's try to think about the brute force solution. So the brute force solution in this case is extremely straightforward. You just go through each element and you don't include that, and other than that element, you get the product of all of the other elements and you store them inside of an array. So this way you are able to get the solution, which is going to run n into n minus 1 times, and that is going to give you the time complexity of n square. Well, this doesn't meet the conditions that we are asked for in the problem, so we are going to think of a optimized solution now. And how can we do that? Well, if you have been following this series, you must have observed a pattern where in this particular case, the thing that we are trying to do is we are, for any middle element, let's say, we want to calculate the product of all the elements to its left and all the elements to its right. And we have seen how we always trade off space for time complexity. So if we can calculate these things and store them somewhere, we can save some time by storing them. So yeah, so that's the idea. So we can store two different values, which is going to be our pre-products and our post-product. And in that way, we will be able to store all the products inside here and all the products inside here. And as we are moving forward, we'll try reducing these values and increasing these values as the product comes up. So the pre-product is going to start at 1 and the post-product is going to be the product of all of these other elements except the first element, and that's going to give you 24 in this case. And as you are moving through the array, you will multiply it with the first element. So for the first case, it's going to be 24. For the second case, you're going to multiply it by 1 and you're going to divide it by 2. Wait, did I just say divide? This particular solution for this problem is out of question. What else can we do for this? So we get the idea. We get the idea that we have to maintain some kind of pre-products and post-products so that we have the values for the elements around products, and we just multiply them together and we get the value. But we can't use this particular approach to this solution because that way we are using division. So how can we avoid division in this case? So if we were maintaining this product in a way that for this particular index, I know that the product is going to be 24. Uh, excuse me. For this particular index, I know that the product is going to be 24. The post product, I know for this particular case, it's going to be 12. And before that, it's going to be uh, 6, I think, or 4, sorry. And in this case, it's going to be 1. So I know these values are going to be this. And how do I know that? Well, because I'm dividing at each step. So at each step, I'm dividing by 2. And what is division? Division is inverse of multiplication. So if I went from here and started multiplying the values, I would have received pretty much the same thing. So this is how I need to think about this particular problem. And so in that way, let's try to maintain a pre-products array and a post-products array. And that way we are going to be able to store these values inside and get the result from the multiplication of all of these indices. So let's see how we can go about doing this. So you again have 1, 2, 3, 4, and you finally want to create two arrays from this, one which represent post products and one which represent pre-products. uh, for the convenience, let's call the above one pre-products and the below one post-products. And how can we go about doing this? Well, we know the pre-product, when we haven't even had anything till now in our array, is gonna be 1 at the start. So this is the default value, and we are gonna fill it up from the next value onwards. So let's try to do that as we are iterating through our array. So in this case, our pre-product for 1 is going to be 1. So that's your default value. For 2, it's going to be the last value in the pre-product into your current value. That is going to be 1. And for 3, which is our second index in our array, the product is going to be the last value in the pre-product and the value that we just left. So that is going to be 2. And for 4, it is going to be 6 by this particular thing that we are following. And for the post products, we again know that for the last value, it's going to be 1 because there's going to be no post value after the last value. And again, we start filling it up in the same way. So 1, then we fill up 4, then we fill up 12, and finally we fill up 24 for 2. Now, if we just multiply these indices together, we are able to obtain our solution. This is 24 because it's going to be 12 into 2 for the last value, which is going to be 24. So these two products are going to be 24. This is going to be 12. These two products, which is the pre and prod for the second index, which is 3, is going to be 8. And finally, for 4, the pre and post products are going to return back 6. So great. So we have a solution. Let's try to code this up, and then we'll try to think a bit more on the way we are writing these loops and try to optimize the code itself. So the understanding is this: the whole concept of the problem comes from this particular idea. And now we are going to go back to our LeetCode terminal, and there we are trying to write up this code. And while writing the code, we'll try to think if there is any way we can simplify the code itself. Right now, what we are doing is we are running a loop where we are calculating the pre-products, then we are running another loop where we are calculating the post-products, and then we are going through the indices or the length of this particular products, and we are multiplying them together to finally obtain our result. So let's try to code this up, and then we'll see if there are simpler solutions available. So here I am back at LeetCode. So first of all, we are going to maintain a pre-prods array, which is gonna be initiated at 1, and we are gonna also maintain a post prods array which is gonna initiate it at 1, but we wanted it the other way around. Well, we can have it in the same way. We can have it in this particular order, as it's simple for us to maintain this. So if we try to calculate it as 1, 4, 12, 24, while we are iterating the array, we will take care that when we are iterating through the length of this particular array, we take the last element from here when we are taking the first element. That way we'll not have to create an array of a particular size and then keep filling those back values using that index. That is a bit more annoying in my head. I like appending values to the slice we are already building up. I don't know. I think the habit comes from Python, and Python is my scapegoat to blame anything I do in coding, I guess, nowadays. But okay, so let's iterate through our nums. So for underscore comma val in nums, range nums, excuse me, I'm gonna fill the pre-prods index plus 1 actually. So I want to iterate the nums except the last value, right? So I don't want to include the last value when I'm calculated the pre-prods. So that for that, I'm just gonna do len minus 1. Well, let's not do that. I don't know. In Golang, I've seen that mostly when we try to use the slices like this, there is overhead of copying those elements inside, because we are again and again recreating a slice that is going to take a copy operation of its own. So rather than doing this, I'll just use a standard for loop where I'm going to instantiate I at 0. I is going to be less than len nums. and I plus plus. And here, to avoid the last element, I can just do len minus 1. So that way the last element is never included. And here I'm going to fill in the preprods I to be equal to and I plus 1 actually, to be equal to preprods I into nums I. So that way I am multiplying the value and finally creating the preprods by using our nums I, which for the first case is going to be our 0th element, which is 1, and for the second is going to be 2. So this way we'll be able to form 1 1 2 6. And just to make sure that we are on the same page, let's just try to print this up once. So fmt dot println, oh my god, I just gonna type today, and preprods, if only I can type. And just to make sure that everything compiles, I'm just gonna return an empty array finally. So let's run this and see if the preprods is actually what we were expecting it to be. And we are still getting compilation errors. Well, if only I don't use my Python habits. Cool, this should be enough. Declared and not use postprods. Yeah, I'll have to comment that out for now because we're not using it anywhere. Golang doesn't let us compile the code till we use everything. And we get an index error. So this is happening because what are we messing up? We are going through len nums minus 1, which is correct. I plus plus is correct. And preprods I plus 1. Well, there is no I plus 1 in the preprods right now. We needed to append this value. So instead of doing it like this, we are going to do preprods is equal to append preprods, comma, the particular value that we want to fill inside, which is the product of the last value in the preprods and our nums I. So let's try running this again. And finally, you obtain the value 1126 as we just discussed on LeetCode. This is what we want from our preprods. Now let's try to create postprods like this, exactly like this. Well, we are already iterating through I and len nums, and we want to do the exact same thing when it comes to our postprods. So can't we do this in the same loop? Why do we have to write two different loops for doing the same thing? So yeah, let's try doing this in the same loop. So here I'm going to do postprods is equal to append postprods. Now what is the particular value that I want to fill inside of it? Well, this is going to remain the same because the ordering is same, but what value inside of nums do I want to multiply to our postprods? So the postprods start at 1. That makes sense. And the first value I want to multiply it is gonna be 4. So to get 4 from 0, I need to do nums I len nums minus I and minus 1. So by doing this, I am ensuring that whenever I am at I at 0, I am going for the last element, which is going to be at len nums minus 1, which is going to be taken care of by I is equal to 0. And when I am at the second element, I am at the second last element, and that way I am maintaining the preprods and postprods at the same time. And if I print that value right now, just so that you guys start believing me, I'm gonna print both of those values. And we are going to see that we will obtain 1126, and our second value is going to be whatever it was. I have completely forgotten what it was. And what is the error now? Undefined postprods. Am I doing a spelling mistake somehow? Oh yeah, there was a small typo here. It was postprods instead of being postprods. So let's try renaming this again. And yeah, you get 1126 and you get 141224. So now I just basically need to iterate through the length of nums and multiply these two values together to finally obtain my results. So I'm going to maintain other array results here. And in here, I'm just going to do int. This is going to be empty at the start of it. I don't need to really fill in anything. And for I in range len nums, I plus plus, I'm going to do pre-prods I into post-prods len nums minus I minus 1. Now again, we are doing len nums minus I minus 1 because we have created the post prods in the opposite order as what we wanted in this particular problem. And that's why we are iterating through it in the reverse fashion. So this we did so that it's easier for us to create the post prods so that we always append in the values rather than backfilling those values. And here we are just inverting the multiplication so that we get the correct values, and this is going to be appended in result. So result is going to be append result comma pre-prods into post-prods, and finally I can now return result. So if I do that, this should solve the problem, just making sure that we don't have any more syntax errors after yesterday. Let's see, declared and not used results. Okay, we don't have a syntax error, but we have a typo for sure. So there are some things that are never going to change. We are always going to receive these angry red messages, and we are always going to be solving them. So that's good. Cool. So it is accepted in both of the cases. Let's try submitting this particular solution and see if this works or not. So drum rolls. So the solution is accepted, but apparently it's not good enough because we are only beating 9.03% when it comes to runtime and 5.87% in memory. Now, what are we doing so wrong? Well, memory, we are certain of that we are using O of an extra memory. We are maintaining two additional arrays to finally reach our result array. And that is kind of a lot of memory in this case. And at the same time, we are doing a whole bunch of append operations, like 3 append operations. So we know that append does cause some kind of overhead in cases of slice because it has to allocate some memory in real time, and that way you have to introduce some overhead as a language when you're providing this increasable slice functionality. So it is understandable why is it taking this long, because we are doing a whole lot of append operations. So how can we simplify this problem by avoiding these many append operations and not using any extra memory at all? And also, if we read the problem description and scroll down just a little bit, we'll see hidden a follow-up problem which asks us if we can solve the problem using O of 1 extra space, and the output array is not counted as additional space, so we don't need to worry about that. So yeah, that's interesting. Let's go back to the whiteboard and try to think of the follow-up problem and solve this in O of 1 time complexity. So we are back at the whiteboard, and let's try to recap what our idea was when we were solving this particular problem. Well, we maintained a pre-prod and a post-prod, and simply we were just multiplying the corresponding indices to finally get our results. Now, is there some way we can finally maintain a results array, and rather than using a pre-prods and a post-prods, we will just calculate everything right inside of that array so that we don't have to use any extra space. Everything is maintained inside of the array itself. So that is the idea. Well, one thing to notice here is that our pre-prods is pretty straightforward. When we calculate our pre-prods, we are just trying to multiply the post-prods as the corresponding indices to calculate our results. So pre-prods in some sense does represent the half picture of what the product is going to look like. So we can just calculate the pre-prods the way we were, and the result is going to be 1126 in that case. And now we finally want to multiply the post products back in to complete this result and include the picture of the post products inside of this array. We could have done that other way around as well. Just pre-prods is pre, it just makes sense to do it before the post prods. So here, what we want to do now is we want to multiply post products of the corresponding indices directly inside of our array so that we can get our final solution. And we want to calculate them as we are going through, as we can't do divide operation. So if we go through the last element, we know for a fact that the post prod for the last element is always going to be 1. So let's maintain, let's just multiply it by 1 for now. And for the second last element, we want to multiply it by the product of the last element and the last element of the array that is given to us. Now, this is where it gets interesting. We are not storing the last element anymore because this element is directly multiplied inside of our results. So The value that we have now is the pre-prod's last index and the last element of our post product. So that way we have lost the information about what this value exactly was. So how can we go about solving this? Well, if we think about it, we can just do it in using a single variable. So if we maintain a post prods and default it at a value of 1, that way we are maintaining a post prod variable which is started at the value of 1. And whenever we multiply anything to it, uh, for example, in the second iteration, we are gonna reach 2, where we want to go through the last element of the array, which is gonna be 4, and we want to multiply 4 by the post prod, and the post prod is gonna become 4. So we are maintaining the post product value which were initially maintained in an array using a single variable and directly multiplying the corresponding indices together. So that way we don't have to create a whole overhead of creating a pre-prods and a post-prods. We directly create a results array, and inside of that results array, instead of maintaining post-prods like this, we are maintaining post-prods by a single variable. And that's how we are able to solve it in O of one time and O of one space. Oh, excuse me, O of n time and O of one space. So let's just update the code to follow up the solution that we just said. So we don't need to maintain the pre-prods and post-prods anymore. We'll just maintain the results. And now we are going to initialize our results at 1 because we want to fill up the results just like we filled up our pre-prods. So I'm just going to replace the variable pre-prods with results. And that's all that we're going to do in our first iteration. So we just fill in the pre-prods and the results is now our pre-prods. Now in the second iteration, what we want to do is we want to again start, we can start at any index. Well, we want to fill in from the last value. So let's anyway do that just to simplify our code logic. And len nums minus 1. This is where we start at. We go till I is greater than 0 because the last value we don't need to take care of anyway. And I plus plus. Cool. So we want to multiply from the first value till the last value. And in fact, we can start from len nums minus 2 because that's where we will want to start filling from. And here we can just use greater than 0. Yeah, because we greater than equal to 0 because we do want to multiply the last element, which is the first element of our results, with the post products of all of the error elements we have seen till now. And as we discussed, we are going to maintain another variable, which is our post prods, which is going to be a simple integer, and that is going to be initiated at 1. So what we are going to do here is we are going to multiply our index, the particular index we are at right now, by our post prods. So results I is going to be equal to post prods. That's it. We don't need a post prods index anymore because it is going to be maintained in a single variable. And we are going to do post prods is equal to nums I minus 1 or plus 1 in fact, because we want to go one step ahead. So the I starts at len nums minus 2, which is 3, because that's where we are starting to fill from, but we actually want to multiply it right here. And in fact, we can start filling from len nums minus 1 as well. So let's not think too much. And this is going to be I in that case. So yeah, post prods is going to be into equal to this. And that way we are going to be maintaining post prods in a single variable. And we are going to fill in the results I with the product of our post prods. And this way we should be able to finally return our results without doing too many append operations, just a single one. And we are also not maintaining two other arrays to finally get to our results. The results is itself going to be built up as the solution follows. So let's try running this to make sure that everything is correct. Oh, there is a runtime error. So index is out of range. And that will happen because we started at lumps I minus 1. So that is correct. And we're gonna go to this, and index 4 is out of range. So how did we reach 4 here? That is tricky. Because we can't reach 4 anyway, because the len nums is always gonna be 4. And we are starting at, oh, we are doing plus plus. Sorry, we are gonna do minus minus. Yeah, silly mistake. And cool. So the solution is working. We are maintaining the results directly, and we don't need the pre-prods and post-prods anymore. The post-prods we are maintaining using a single variable now. So I hope the solution makes sense. And this was just a silly bug. I just forgot to update it as minus minus, as we are doing the iteration in reverse order now. We are not going left to right. We are going right to left. And so this is working. Let's try submitting if everything is working or not. Drum rolls. Cool. So now we are beating 33.29% in runtime, which is much better than the last time. And we are beating 59.38% in memory because we are using O of 1 memory. And we are also able to solve the follow-up question, which is to solve the problem in O of 1 space complexity. So cool. I hope the solution made sense to you guys. If it did, please like and subscribe the video. And if you have any doubt, please let me know in the comments down below. I'm always happy to answer, and see you next time. Bye bye.